Okay, so we're talking about actually solving a system of two equations to find the X and the Y values that work for both equations. And one way to do that, and a very important way, is graph the equations and see where the two lines meet. It's not a practical way to get an exact solution, but it shows you something about graphs that's really important, okay? And then we learn to use a simple method to find the exact solution. All right, so first of all, now a lot of people started graphing this equation by finding the slope and the intercept, okay? That's certainly a valid way to find it, to graph an equation, but it's much simpler to find the intercepts. X equals 0, 6 times 0 minus 4y equals 36. 6 times 0 is 0. And I'm going to emphasize that because not everybody is really seeing that. You write 6 times 0, and I've seen a couple of people try to subtract 6 from this. Okay? If you did it, you're not alone. Okay? So everybody's got company. It's 0 minus 4y, which is just negative 4y equals 36. And then you divide and you get y equals negative 9. Now, from this step on, everybody is fine. I haven't seen any mistakes there, but I'm seeing mistakes in this step. First mistake I'm seeing is people are not finding the intercept. Okay, they get x equals 0 and they solve for y, and then what's this tell you? This tells you when x equals 0, y equals negative 9. This equation. So the point 0, negative 9 is on the graph. If you plug in 0 for x and negative 9 for y, you're going to get 36 equals 36, meaning that this point is on the graph, and it's the easiest point to find other than the y-intercept, which is the x-intercept, which is also equal. If y equals 0, then you get 6x minus 4 times 0 equals 36. So that 6x equals 36. I didn't bother to write the rest of this side like I did here, but 4 times 0 is 0, so you just end up with a negative 4y. 4 times 0 is 0 on the left-hand side. That means you just end up with the 6x. And without writing the details of the step, we get x. So the x-intercept is 6, 0. So now I can sketch this graph on a nice straight y-axis, set of x-y axes. Okay, I've got the point 0, negative 9. Well, I'm going to put y equals negative 9 down here. I'm going to put x equals 6 about here. Now, here's the point 0, negative 9. And here's the point 6, 0. And I can draw the straight line through those points. Now, see, I missed that one. I didn't start carefully enough. I hit this one because I was looking at it. But I didn't look right when I started. So this isn't going to be a completely accurate line. Now, actually, when I do this, I always hit the lines right in the points right in the middle. I never make a mistake, but I pretended to because you might. Okay. Well, yeah, okay. My big point here is that these lines are never 100% accurate. Okay. Now I want to find the intercepts in the second equation. How is this? If x equals 0, we get 5y equals 20, so y equals 4. So the y-intercept is 0, 4. If y equals 0, we can just look at this equation and see that 5y is going to be 0. Then we're going to have 4x equals 20. So the x-intercept is 5, 0. I didn't work this out in all the detail. I did this one, but you should work it out in all this detail. Okay? Unless you got the intercepts and got a good graph. Okay? If you did manage to get the intercepts and get a good graph, then you know. Now, the thing that we understand, having done the assignment on intercepts, is the intercepts are the points where the graph hits an axis. On each axis, either x or y is 0. On the y-axis, well, y can take all kinds of values, but x is always 0. On the x-axis, x can take any value, but y is always 0. That's why we say we start with, okay, let's let x equal 0 and see what the point is. The other thing people do is they're not quite understanding that when you plug in 0 here and get -9 for y, that gives you the point. X is 0, y is -9. Okay? Too many people will do this and get -9 and write down, okay, so there's the y-intercept. You want to write that down right away. Then, when you get the y, you realize that the y is 0, x is 6, that gives you the 0.60, that's the x-intercept. You want to write that down. Otherwise, you're going to do what most people do, is think that the point -96 is on that graph. Okay? It's clearly not on that graph. I mean, there's the graph and the point, I said -96, but the point 6, -9 would be down here. That's not a point on the graph. When x is, or when y is -9, x sure is not 6. When x is 6, y is certainly not -9. Okay, so I want to emphasize that. I want you to be sure you understand that. Okay, so we can plot these points on the graph. 0, 4. Well, let's see. Now, if that's 9, then 4 is about this big, so that point ought to go about here. And 5, 0. Well, if that's 6, then this should be about 5. And now when I draw my straight line, see, I went right through the points. When I draw my straight line, I estimate what these coordinates are. So here's my point of intersection. I draw this line here. If this is x equals 6, this is between 5 and 6. I'm going to say this is a line x equals 5.4. Actually, I'm going to say 5.6 because it looks like it's a little closer to 6 than it is to 5. And here's x equals 6. Here's the line where x equals 5. And this line is actually closer to 6 than 5, the way I've drawn it. Okay. Now, I don't have a completely accurate coordinate system. That's okay, as long as it's pretty good, pretty representative, reasonably okay. It's not going to give me a perfect answer. If you want a better answer, get some graph paper, all lined off with a grid, and make an appropriate graph. Okay, but I don't recommend you do that. I recommend you locate line x equals 6. Then if this is 6, you think 5's about there. Locate y equals -9. If -9 is that, then 4 is about this. 4 and 4 makes almost 9. This graph is pretty well to scale. I expect I'm going to get a reasonable result. Okay, then question is, what about this horizontal line here? Oh, we're keeping the darn thing straight. Okay. If this is how big 4 is, then this is how big 2 is, and this is how big 1 is. So this looks like it's maybe about x equals -0.3. Now let's see if we close to that point. They appear to me at approximately 5.6 -0.3. Let's check. If x equals 5.6, y equals -0.3, then 6x minus 4y equals 36 becomes 6 times 5.6 minus 4 times -0.3 equals 36. What have I done? I said, well, if x is 5.6 and y is -0.3, then I replace x by 5.6, I replace y by -0.3, and see what that gives me. If I'm completely wrong, it's going to give me 36. If the graph is pretty much right, but because it's a hand-drawn graph, it's not completely accurate, it should give me a number close to 36. Okay? Maybe 37 or 38, maybe 34, 35. You know, if I get a number close to 36, it's going to convince me that my solution is reasonably close to this. Okay? As long as solution does equally well in the other equation. So let's see, 6 times 5.6 is 33. -4 times -0.3 is 1.2. And wait a minute, 36 subtracting. So I should be subtracting 3.6. Should be 32.4. Okay, so I get 33.6 equals 36. Pretty close. It's not great, but it's pretty close. All right. Wait a minute. I'm doing the wrong thing. That should be 33.6. I'm being fancy. I had it right the first time, so it's even better. And this is going to be 34.0. Okay, that's even closer, but it's still off by over 1. Okay. Now we check. Check the second equation. We get 4 times if this thing hasn't been recording. I have to go over all this again because I don't know what this thing was doing. Neither does it. It's okay, it's worth going over again. Okay, I guess it's recording. Supposedly it's been recording all along. Okay, let's assume it's been recording. This is not great. This is pretty close to this. This is kind of close to this, okay? For a hand-drawn graph, I don't expect to do a whole lot better. Now we'll see what the accurate solution is, but I don't know what Zoom is doing. Right in the middle of what should have been recording, it said, we're recording. I didn't touch a thing. And you got to keep an eye on Zoom. I'd like to be able to keep an eye on this and you, because you all really need people. But matter with you, Zoom. Okay. I'll thrash Zoom later, as soon as I can get a hold of it. Okay. Probably end up in the hospital. Okay. Now, what I've asked you to do, and if this is very repetitive with what you've already seen, it's Zoom's fault. Okay. I suppose it's been recording all along, and maybe it wasn't. So we graph these equations on the same set of coordinate axes. I've done that. And what I've done is I've followed the logic. All this logic is essential. You should be writing out everything in the same order, not skipping anything when you do these. Okay? So we graph 6x minus 4y equals 36. We want to find the intercepts because it's really easy to let either x or y equal 0. If we let x equal 0, we're going to get a y. Well, that's going to give us a point where x is 0 and y is some number. Like we let x equal 0, we get y equals 6. Okay? If we let y equal 0, we get x equals 5. And this see why I didn't get a completely accurate graph. At this point, never mind. Okay, this is 6, 0, this is 0. We know. Okay, now let's see how we get this. This is the graph we get. We're going to get a graph for this first line, and we're going to get a graph for the second line by the intercepts. Okay, if we let x equal 0, we're going to find the y-intercept. If x equals 0, we have 6 times 0 minus 4y equals 36. Just replacing this x by 0. Now, people are wanting, a couple of people tried to subtract 6 from 6 times 0. Okay, well, 6 times 0 is 0. You don't have to subtract 6 from that. It's just 0. It has a value which is 0, making the left-hand side 0 minus 4y equals 36. And of course, now we don't need to write that 0. We get negative 4y equals 36. And then very quickly, with steps that you don't want to skip, you end up with y equals negative 9, telling us that the y-intercept is at 0, negative 9. Now, all I did was I said, okay, how low do I want negative 9 to be? Well, I want it to be down about here. So I drew a horizontal line here, and that line is y equals negative 9. Now, because of the dots in the line, that might look like negative 9 equals negative y equals negative 9. I'll put a circle around the equation. And before we go on to the next steps, we don't get confused and do the thing 90% of the people do. We lock this in. When x is 0, y is negative 9. So we have the point 0, negative 9. Okay. Well, then we let y equal 0. That's going to give us 0 here, leaving us 6x equals 36, x equals 6. So x is 6 when y is 0. So that gives us the point 6, 0. Frequently, very frequently, people will think, they write this out and they'll write this out. They won't write this out, won't write this out, but they'll write 6, negative 9 as a point on the graph. 6, negative 9 is not a point in the graph. When x equals 6, y does not equal negative 9. You can replace x with 6 and y with negative 9. You're going to get 72, not 36. Okay? It's not a point on the line. This is a point on the line, and this is a point on the line. So make sure you avoid that mistake. If you're doing this without thinking about what it all means, just doing it by habit, you might get all the steps right, but you might say, okay, there's a point. And that's only one point. You don't even have another point on the line. You can't draw a line. Write this out as soon as you found the y-intercept. Write out the y-intercept is this, so you won't try to use that negative 9 and combine it with a 6. And then write out, so the x-intercept is 6, 0. Well, we put those points on the graph. I drew a vertical line corresponding to x equals 6 here. And then here's the y-intercept. Here's the x-intercept of the first line. Now we do the same thing for the second line. I did it more briefly. If x equals 0 for the second equation, then let's write the second equation out. It would have been good to do that. Okay, there's the equation. If x is 0, the 4x is 0, and it just leaves us 5y equals 20. And you can divide that both sides by 5, so you get y equals 4. Now, I'm writing it out briefly. I want you to write it out with the steps, so you keep reinforcing the steps. Okay? Because you need reinforcement of those steps. Otherwise, you're going to start forgetting steps, or you're going to be prone to forget. Anyhow, I abbreviate like all this stuff, but with this equation. And then I write y-intercept is 0, 4. Why? Because x equals 0, y equals 4. If x equals 0, y has to be 4 in order for this equation to be true. Similarly, if y equals 0, well, we substitute 0 for y, the 5y goes away, we get 4x equals 20, and x equals 5. So the x-intercept is 5, 0. Again, always write this out as soon as you've got it. Write this out as soon as you've got it. Write this out as soon as you've got it to avoid a fatal error. Well, I skipped then a couple of points, 0, 4, you know. If this is 9, this seems about 4. There's 4, 4, 8, 9. Okay. So it might be a little high, might be a little low, but it's close. And then 5, 0. Now, if this is 6, this should be 5. I could have divided 6 in half and I got 3 here and I say 4, 5. Okay, there it is. It's about there. Now I estimate the coordinates of the point where the two lines intersect. Lines intersect here. I draw a vertical line through here so I can see clearly how close this line is to x equals 6. And turns out it's pretty close. I estimated 5.6 after fudging a couple of times, or changing my mind a couple of times. I didn't fudge anything, or I got closer to the right answer. Okay. And then this line, I said, well, if this is 4, this is 2, this is 1, so 1 is down here. That looks like it's about negative 0.3. The x coordinate looks to be about negative 0.3. I've got that horizontal line through this point, so I can see how close that is to 0. All right. Then I checked. I checked to see if 5.6 negative 0.3 is a solution. X equals 5.6, y equals negative 0.3. I take the first equation, here it is. I say, and I write, if f is 5.6, y is negative 0.3. You write those words. Write those words every time you graph an equation by intercepts, and it'll become much clearer to you what to do, and you're going to be much less likely to forget when you get to a test. Okay? So if x is 5.6, y is negative 0.3. If x is 0.6 and y is negative 0.3, then this equation, 6x minus 4y equals 36, becomes 6 times 5.6, because x is 5.6, minus 4 times negative 0.3, because y is negative 0.3. I do the multiplication, finally get it right. I get 33.6 plus 1.2 equals 36, giving me 34.8 equals 36. That's close. It's not bad for a hand-drawn graph. I'd like to have it a little closer. And I think I've said it's probably on there. If you want to get a really close result, get yourself some good graph paper and sketch the graph, a big graph on good graph paper, because you can't estimate a little graph very accurately. I recommend just do it by hand. You get a more tactile sensation. You get a tactile sensation with a graph paper, but you have to think a little bit more about what your scale means if you just do it by hand. Okay. Okay, then we check 4x plus 5y is 20. And it turns out that that doesn't work out quite as well. We get 16.4 equals 20, which is not great, but it's not terrible. It convinces me that my solution had better be pretty close to what I got here. Okay, now I'm going to proceed to solve the equations accurately. The graph is good for understanding the overall picture. You want that overall picture. You absolutely need to do these graphs. And as I say, sketch them yourself, not just on the Open Math interface. Okay, 6x minus 4y equals 36. Where is it? 4x plus 5y equals 20. Okay, now I'm going to use notation. I'm going to use a circle 1 and a circle 2. Circle 1 stands for this equation. The circle 2 stands for this equation. I'm going to solve the first equation, and I'm going to solve it for y. Now, incidentally, some of you did choose to solve these equations for y and then graph them. I think you can see that the intercept method is much simpler in the case of these equations than the slope intercept. Because in the slope intercept, you only got 1 point, which is the intercept. And then you got to deal with the slope. Okay? And when you do that, you're probably going to do it in a way that gives you something a little bit less accurate than you would if you use these intercepts. Now, if the intercepts are very close to the origin, then slope intercept is really a better way to graph it. But if the intercepts are out away from the origin, the intercept method is going to probably give you a more accurate graph. Okay, so anyhow, we're going to solve first equation for y. So we got 6x minus 4y equals 36. Solve for y, so we're going to subtract 6x from both sides. And we get negative 4y equals 36 minus 6x. Probably should have put the minus 6x out here. So I'm lining up x's with x's and numbers with numbers and all that stuff. Okay, well then all I have to do is divide by negative 4. And I get y equals negative 9 plus 3/2 x. Okay, that's very easy. I could have solved the second equation for y. I could have solved the first equation for x, or the second equation for x. I solved one of the equations for one of the variables. I chose the first equation to solve for y because that gives you kind of the nicest numbers, but you might not be able to anticipate that. It doesn't matter as long as you do it accurately. Pick either x or y, pick either the first or the second equation, and solve that equation for the variable that you picked. Now I've got this. I'm going to take this and plug it into the second equation. Because this came from the first equation, I'm not going to plug it into the first equation. Okay, I'm going to plug it into the second equation. So in the second equation, I plug the y in here, and that gives me 4x, run it out differently. Just with some colors. Distinguish what I'm changing. Got 4x plus 5y, right? Well, y is now negative 9 plus 3/2 x, so I'm going to replace y with that, and I get equals 20. Then I use the distributive law. In the interest of time, I didn't write the intermediate step. You should write that step. 5 times negative 9 plus 5 times 3/2. Now I multiply both sides by 2. Why do I do that? Because when I do 2 times 4x is 8x. Two times negative 45 is 90. 2 times 15 halves x is 15x. The 2 that I multiply by the 15 halves is divided by the 2 here. It just leaves me 15. And now I don't have any fractions to confuse the issue. So I go ahead and bring this up here, rewrite it just so we can see it clearly. 8x minus 90 plus 15x equals 40. Make sure that's on screen. Yeah, we're good. Okay. Well, 8x and 15x is 23x. 23x minus 90 equals 40. I'll do the thing that y'all like to do. Add the equation 90 equals 90, and I get 23x equals 130. 23x over 23 equals 130 over 23. So that x is 130 over 23. Now that comes out 5 times 23 is 115. It's 5 and 15. Yeah, 5 and 15 23rds. Okay. Now 15 23rds is pretty darn close to 0.6. So my 5.6 actually turned out to be a pretty good estimate. But somehow my y didn't come out that nicely. Well, now let's find y. Now this becomes 6 times 130 over 23 minus 4y equals 36. Now I can multiply the 6 by the 130. I get 780 over 23 minus 4y equals 36. And before I go any further, I multiply both sides by 23. So I don't have to deal with a really ugly fraction. Unfortunately, I'm going to end up dealing with some pretty big numbers. Okay. Well, this gives me then 23 times 780 over 23 is 780. 23 times negative 4 is negative 92y. Well, times negative 4y is negative 92y. And somebody quick in their head, multiply 23 by 36. Well, I'll do it in my head. 3 times 36 is 108. And 20 times 36 is 720, so it's 828. I think. Did you get it? Good, that checks out. Everybody needs to check their calculator. So that was a good check. Your calculator's okay. Okay. That's actually a pretty easy multiplication. It's just, in my case, working memory can be a little bit of a problem. So I'll just write that out again. There it is. You add 780 to both sides. You get negative 92y equals 1608. So y equals negative 1608 over 92. Let's see, which equals that divisible by 8. That is, it says, doesn't help. That's negative 804. Six, that should have divided again. What I'm dividing by is 4, not 8. So let me go ahead and divide by 4. That's 402 over our good friend 23. Okay. Now, you work out these details. Fractions are ugly. You're going to have to use a calculator to multiply them, but the procedures are the same for all fractions. Okay. And there's something terribly wrong with that solution. Oh, heck. I looked at the negative sign on the 92 and thought there's a negative sign on the 780. So that's all messed up. So from the 1608 down, I can tell it's all messed up because when I divide 402 by 23, I get something around 20. And I know that the y coordinate of the intersection here isn't close to 20. Okay, so there's one advantage of the graph. The graph told me that that number that I had there, that probably shouldn't have erased, but it was going to be a number that was pretty close to 20, and that's way off. That can't possibly be right if my graphical estimate, wherever I went with it, my graphical estimate of the solution x equals 5.6, y equals negative 0.3, if that was going to be accurate, reasonably accurate, which it appears to be, especially since this solution came out pretty close to 5.6. Got down here, it just was not going to be right. So it should not have been 1608. It should have been 38. Because I should have subtracted 780 from both sides. So y is negative over 92. In decimal place, okay, so my solution is x equals 130 over 23. Y equals, now this can be reduced. And that shouldn't be 38, it should be 48. That gives me negative 12 over 23. This is approximately 5.6 negative 0.5 instead of the negative 0.3. Now you can plug that in and see that it should give you something much closer quality on both of these. You know why this didn't come out closer? My y was supposed to be 0.3. I used the 1.2 that I had up here for no reason that I can in any way explain, except that my brain, which did its arithmetic pretty well on a good day, doesn't seem to be able to some other things. Right, this should have been 0.3, negative 0.3, not plus 1.2. Come out very close. (23.9) equals 20. My comment is that this isn't so great. It's awful close to this solution. This makes it even worse. So something isn't quite right here, so there is a good chance I made a mistake in some of this. Now, the point isn't the arithmetic, although you should be able to do that arithmetic. It's a little tedious. Takes a little while to do. It's not a whole lot of fun. But what's the procedure? Let's review where we are without getting hung up on the details of the arithmetic and on checking this thing that still doesn't seem to check out real well. Okay. Yeah, 6x minus, well, here are two equations, original two equations that we graphed. And we got the estimated solution, x equals 5.6, y equals negative 0.3. I also did another bonehead thing over here. This still on the screen. Yep. I said this is x is about negative 0.3, and that's actually obviously that's y. It's a horizontal line. A little carelessness there. Okay, what we do here is we solve one of the equations for x or y. I just chose the first equation to solve for y because the numbers came out a little easier than they would if I'd have chosen the first equation to solve for x or solve the second equation for y or for x. Okay, that's just the one I chose. It doesn't matter as long as you do the arithmetic right. Okay. So I solve the first equation for y, and I find that y equals negative 9 plus 3/2 x. Okay. And what do I do with that? Well, that's a value of y expressed in terms of x. I plug that into my second equation. I don't plug it into my first equation because I want to use different equations to get the result. So since I got this from the first equation, I plug this result into the second equation. Okay, when I plug this in for y, I get all of these expressions except y is replaced by this expression. There it is. Now I multiply 5 by both sides here, and I get this. And then I clear out my fraction by multiplying both sides by the denominator. And I get this. I'm kind of checking it as I go. And then I write the equation up here again. I'm smudged and handling the board, but there's same equation. And we solve it. And we get x equals 130 over 23, which comes out Pretty close to my estimate, 5.6. Okay. Then we take that value of X and plug it in for X and solve for Y. And when we do that, pretty sure this is right. And that equation gives us negative 92y equals 48. Y is negative 48 over 92, which is about 12 over 23, which is a little more than negative 0.5, slightly negative 0.53 or something like that, 5.4. If I plug these numbers, or these numbers, these accurate numbers, into the equation, both equations should give me the same thing on both sides. I'm not going to do that because it's denominator there and you get big numbers. But that's the process. And that's a process OpenMath is going to describe to you. Okay. And their examples are going to have simpler numbers in them. And most of the problems will have simpler numbers. I don't think you're ever going to have fractions that end up with a denominator of 23. Although if you do, you should be able to handle it. Okay. If you're just careful and don't make as many mistakes as I do. Okay. So, for some reason, people didn't get that assignment of graphing the two equations, which was due last night, but I, because of all the disruptions, snow and stuff, I just moved that to today, and then tomorrow, this method. Okay. Get those two methods down. And then we got one more method for solving these things. And then we have spring break where you don't have an assignment. Okay. Now I will mention, I mentioned that you have a test coming up, haven't I? Sent you sample problems and stuff. Well, it's been testing center for over a week. I didn't expect anybody to get it done then, but that test is going to be due I don't like to give an assignment over spring break. It'd be best for you if you get it done by the end of the week, but it'll be available until a week from tomorrow, 2 weeks from tomorrow. Second day when you come back from spring break. Fair enough? I send you out a sample. If you want more samples, ask. If you didn't get the sample, ask me. I can't email anything right now because my email's screwed up. But you guys gonna come over and reinstall my Outlook. I can read your emails. I can't open your attachments and I can't reply. So I can get what you send me, but I can't do anything else with it. But don't hesitate to send me questions. If it's something that's really timely and you really need it, I'll use my Gmail account, which is through the system also. I will say if I do email you from the Gmail account, don't email me back through the Gmail. I won't be checking. Email me back through the regular thing unless I ask you to do otherwise, okay? Hopefully by this evening, everything will be fine. Nobody understands what's going on with that Outlook, so hopefully we'll get that straight.